All right, 1.6, first day, we're solving compound inequalities, and then the second half of this lesson will be solving the absolute value inequalities. So for the compound inequalities, um, both inequalities must be true if it is an and. So if it's an and, both inequalities must be true. Okay, so an example in the real world, I want to be a millionaire and not work. Now that's an and, it has to be both. Um, so a math example, 2 is less than x is less than 10. And if you read this backwards, where the and is, you got to read the x backwards. X is greater than 2. If you go x is greater than 2, and then reading forwards, x is less than 10. So with an and, yellow and blue make green. All the numbers that are true, when you mix those two, that's what will be true, like 5, 6, 7, and any other real numbers, decimals in between there. So when you see something written like this, you have now we have three sides to our equation. Okay, so that's only going to happen for an and. It could be written separately, but it's usually easier to write them together. Okay, so that means when we go to solve them, okay, I'm looking to identify, hey, I have two inequalities, and they're always for an and, they should both be less thans. Okay, so we see that on both of these. So solving it, what you do to one side, you got to do everywhere. So I'm going to go ahead, 4x plus 8, we're going to go ahead and subtract 8 from everything. So we subtract 8 from all three sides of the equation, because we have a left, a middle, and a right. So negative 12 and negative 8, negative 20 is less than 4x, which is less than 32 minus 8, 24. Okay, and then of course we're going to do the same thing for our next step. What you do to the middle of the equation, you also have to do the left and right. We got negative 4, or we got to divide by 4. So then negative 20 divided by 4, negative 5 is less than x, and then 24 divided by 4, less than 6. Okay, so again, with an and inequality, it has to be both. So let's go ahead and plot some points on the number line. And we're going to come down here, and let's go ahead and put negative 5. I'm just going to eyeball over here. I'm going to put 0. And I like to use 0 as one of my points in the middle. I always want to pick a point in the middle. And then I'm going to pick 6. Okay, now these would all be open endpoints. So when I go to graph this then, okay, I'll have open endpoints. That's open. That's open. Now if we think about that highlighter thing that I was doing before, okay, all the numbers, again, x is greater than 5, so that's all of those numbers. And or sorry, x is all the numbers less than 6, all those. All the numbers greater than 5 is all of those. And of course, that's what I really want to graph, is where those numbers overlap. So what I'm graphing on my number line is all the numbers between 5 and 6. And that is for an and inequality. Another example here. Again, I got three sides. I have a left, a right, and a middle. So I'm going to solve it just like I would if I only had two sides. I'm I'm going to add 2 to everything because opposite of subtraction is addition. Okay, and then so 10 plus 2, that's 12, is less than or equal to 3y, is less than or equal to 21, and then I'll divide everything by 3. And if you thought my writing on the board was messy, I'm trying to draw with the mouse, so doing my best. 4 is less than or equal to y is less than or equal to 7. Okay, so I don't have as many points this time. I'm going to kind of skip that intermediate step of like talking about where they overlap. You don't have to do that. 4, I'm going to go ahead and put that on the numbered line, 4. And since there aren't very many, maybe I'll just put 4, 5, 6, 7. This time, they both have an equal to with the inequality symbol. So on this one, we're going to do a solid point, solid endpoint, because we are including the endpoints. And then, of course, we're going to graph in between them and shade in between. And, of course, going back up to that, 5 and 6 are both in between those numbers. Now, it's also possible with an and inequality that one of those inequality symbols is open and one is closed. That can also happen. Okay. Next example, or inequalities. Ors, there's always going to be 2 separate equations. So on an or, we always are going to see 2 separate equations. We're going to have to solve 2 of them. And let's see here. Or inequalities must pass both. So one or both inequalities must be true. Or one or the other, actually, is what I'm going to say. One or the other. Okay? So now, you could have both true. So example, in the real world, I will go to the movies or out to dinner. So if either of those is true, it's true. It also could be I will go. You could go for dinner and a movie. They're both true. If you go out for dinner, then go for a movie, then an or might still be true. Okay. Solving this again, simple one to solve. We are looking at my first equation. Simple one to solve. Let's subtract 3 from both sides. My 3 has too many bumps there. X is less than -1 minus 3, -4. So x is less than 4. The second equation, I have a negative x. It looks like there might be a typo on the notes page that's copied. Negative x is less than or equal to -4. When I divide or multiply by -1 to get rid of the negative, then that will be a positive x. And now we're going to flip the symbol. X is greater than or equal to, because we divided by negative, 4 divided by -1, greater than or equal to +4. So here is an example where we have, one is going to be open, one is going to be closed. So x is less than -4. Okay, so that's going to be open, shaded to the right. Okay, I'm going to just go ahead and plot 0 in the middle here. And here is the +4. Okay, so then we could go to the positive side, and that has a closed endpoint. So I'll go ahead and shade that side. And notice that your test point in the middle of 0 makes both of those inequalities false. So that's why we're not shading in the middle. Let's look at the next one. Let's see here. M minus 7 is greater than 12. So if we solve that, let's add 7. Add 7. M is greater than negative 5. On the other side, we need to flip and rewrite that equation. So on the other side, so now that's one of my equations. That's one of my answers. Okay, on the other side, we were initially given a negative 3 m plus 2 is greater than 28. So what we need to do, we need to multiply the whole equation by a negative and flip the sign. So I would always do that if you have a negative in front of the variable. Flip it right away. So we're going to start off with 3m plus a negative 2 is less than 38. Oh, that's a negative 38. Almost gave out laugh tapping. 3m, let's add 2. We add the 2. 3m is less than negative 36. Okay, divide by 3. And if you divide that by 3, that says m is less than negative 12. Okay, so on this one, let's see what happens. M is greater than negative 5. So let's see, let's think about this. Negative 5 is out here. Here's negative, let's say negative 8. And then negative 12 is like down here somewhere. So greater than negative 5, that will be an open circle on 5. And that's going to shade going to the right. Okay, and then less than negative 12, that's going to be an open circle on negative 12, and that's going to shade going to the left. So again, negative 8 is making both of those false, no shading in the middle, we're shading the ends. An OR inequality usually shades the ends. Let's look at, I think, 2 more examples for today, and then day 2 will be the absolute values, but I think we have an assignment and then a delta math assignment as well in between before we'll do day 2. So if we look at this, let's see here, we got an and inequality, and these examples are going to be examples where when you're working with these, all real numbers is a possibility, no solution is a possibility. So that's what we're going to see here. Backside. Let's solve this one. Subtract 2. This is an and written separately. So we subtract 2. So what do we got? We got 13x is less than or equal to negative 26. Divide by 13. X is less than or equal to what? Negative 2. So x is less than or equal to negative 2. Let's solve the other one. If we solve the other one, let's see what we got. We got add 10. And we get 2x is greater than or equal to 21. Divide by 2. X is greater than or equal to 10.5. Okay, so let's look at what we got going on. And this is an and inequality, so it needs to be both. So let's see here. There's, let's plot negative 2. Let's see, there's 0. See, 10.5. We're just going to eyeball that, label an underline 10.5. And less than or equal to. So less than or equal to, that's going to be a closed circle. Let's think about this. Let's do this with the highlighter again. So highlighter less than or equal to 2. Wrong color highlighter. Oh, that'll work. Less than or equal to 2. That would be a closed circle on -2 going to the left. Okay, in the other color, that's a closed circle going to the right. All numbers bigger than that. And this time, I have no section in the middle where blue overlaps yellow to get green. So this one is no solution. If you are lazy and you don't want to write out no solution, there is a shortcut for that. You could write the empty set symbol, which is just that symbol there. Draw a circle, put a line through it. Okay. And finally, the last one. Let's do this one here. What do we have? We've got x plus 5 is greater than or equal to, or greater than -2. So let's subtract 5 from both sides. X is greater than, let's see, it's -2 minus 5, -7. Or, on the other one, let's divide by 11. And that one would be x is less than 7. So let's see, we got x is greater than -7. So there's -7. Let's put 0 on there. Let's put 7 on there. And what are we doing? We're putting an open circle there, kind of. We're going all the way to the right. Okay, and then we put an open circle here. But guess what? That one was already, it would be an open circle, but it's already closed in. That's going all the way to the left. So really, this, if we would plot those points, it's one or the other or both, makes it true. We're shading the whole number line. When you have an or where you're shading the whole number line, we don't really want to draw the open circles because that's confusing and incorrect. Or you could do all reals, would also be a correct answer. If you're lazy and you want a shortcut symbol, remember this is the symbol for all real numbers. So if you want to write the shortcut symbol, you could write the shortcut symbol. Okay, for the homework assignment, we have 1.6 practice A.